Hey, it's Dr. J. Moving on to Chapter 7 today, and probably for the rest of the week. We'll start with, obviously, 7.1, Trigonometric Identities. Before we do any trigonometric identity problems, let's just talk a little bit about the 6 trig functions on the unit circle. So the unit circle is x squared plus y squared equals 1. Just as the name implies, it is a circle of radius 1, centered at the origin. That's good enough. If I try to make it any better, I'll probably just make it worse. So there we go. We have a circle centered at the origin of radius 1. We're going to let T be the angle in radians. T could also be given in degrees, but for this particular presentation, I'm going to use radians. Maybe we'll come back and do a quick review at some point about the difference between radians and degrees. I don't want to get hung up on that right now. So given any point on the unit circle, x comma y, where the angle, the central angle here at the origin is t, we define sine of t to be the y value of this point, and cosine of t to be the x value. You really only need to memorize these two. I mean, I want you to memorize all 6. But for practical purposes, if you just memorize these two, sine and cosine, you can get the rest of them for free. All right, so what are the ones you get for free? Well, you get tangent. Tangent is y over x. It's the same thing as slope, y over x. Then you get its cofunction, cotangent, x over y. Okay. You also get secant. Secant is 1 over x, and its cofunction, cosecant, is 1 over y. So I recommend memorizing sine and cosine, and then you get tangent, cotangent, secant, and cosecant for free. Buy 2, get 4 free. An identity is an equation that is true for every value of the variable in the domain. In a future lecture, I'll spend more time talking about the particular domain of each of these functions as we get deeper into the section. But for now, you can just think of an identity is true for every value. That's a good enough definition for this particular lesson. So notice we're going to be able to create our basic identities right now by just looking at these relationships on the unit circle. So these are our basic identities. Basic meaning they come directly from the definition. So from these definitions, we get some simple identities. Let's go ahead and start with tangent. See? Tangent is y over x, but y is sine and x is cosine. So tangent is sine over cosine. Each one of these definitions will give us a basic identity that we can use throughout this chapter. Cotangent, well, cotangent is x over y. X is cosine, y is sine. All right. And then we have what are called the reciprocal identities. Secant. Secant is 1 over x. Well, that's 1 over cosine. Cosecant. Cosecant is 1 over y. Well, that's 1 over sine. And then you might notice we get 2 more reciprocal identities here. 2 more reciprocal identities. Erase these arrows. Tangent is 1 over cotangent. And cotangent is 1 over tangent. So there are 6 basic identities. You have 4 reciprocal and 2 ratio identities. These are the 2 ratio identities, and these are reciprocal identities. I guess you can consider them all ratios, right? They're all fractions, but these 4 are in particular reciprocal fractions when these 2 are just ratios of sine and cosine. Okay, so take a good look at these. You should have them well memorized at some point. For now, you can keep them as a reference. And let's do some examples. Example 1, simplify. Now, I have a general definition of simplify in this particular section. When I say simplify, I mean write as a single trig function. Or a constant, if possible. So that's my general definition of simplify throughout the lesson. Okay. All right, let's start with one. Secant times cotangent. Simplify this expression, right, as a single trig function, or if possible, a constant. All right. So we have secant. Let's work down, actually. I think it's easier to work vertically. So secant is 1 over cosine. Cotangent is cosine over sine, which is cosine over cosine sine. The cosines divide out. It essentially becomes 1. Cosine divided by cosine is 1. You get 1 over sine. And so this is cosecant. Okay. And so this is an identity. Anytime you simplify an expression, you are creating an identity. You just write an equation using the first expression and your final simplification. Just ignore everything in the middle. And now you have an identity. Secant t times cotangent t is equal to cosecant t. So this equation is always true for every value of t, provided that t is in the domain of the function. Again, for now, you can just consider this as always true. We'll get to the specific values in the domain later. Okay, example 2. Simplify sine t times cosecant t. You might notice that when I listed out all the basic identities, there is no basic identity to rewrite sine. So when you are given sine, you just leave it alone. Sine and cosine are left unchanged. It's only the other 4 trig functions that you'll be rewriting in terms of either sine or cosine. So you want to leave sine as sine, but you want to rewrite cosecant as 1 over sine. So this becomes sine t over sine t, which is equal to 1. So that's what I mean about a constant if possible. Typically, that constant is 1. Sometimes it comes out to be -1, depending on what we're doing. Okay. And again, you have a new identity. Every time you do this, you are basically creating a new identity. There are an infinite number of possible identities. You obviously can't memorize an infinite number of something, but you can certainly, every time you do a problem, you can put that in your memory and go, okay, I've seen that one before. I remember that's an identity. That's an identity. So we have a new identity. This one's pretty obvious, right? Sine times its reciprocal. Any number times its reciprocal is always going to be 1. All right, so how about this one? Simplify tangent t over secant t. Tangent is sine over cosine. Secant is 1 over cosine. You're going to turn this into multiplication. You take the denominator and you multiply by the reciprocal. So the reciprocal of 1 over cosine is cosine over 1. Cosine divided by cosine is again 1. So this becomes sine t over 1, which is just sine t. Okay. And I could say it again. You now have a new identity. Tangent over secant is always equal to sine. If you do want to get lazy with your writing, there's an acceptable amount of laziness. The parentheses are optional. At least they're optional on paper or on the whiteboard. When you're typing these on your computer, the parentheses are required on the computer. But they are not required on paper. So you could get away with writing them a little bit easier when you're doing your scratch work or something. Some people get really lazy and they don't write the t at all. They just write tan and sec and sine. That's bad form. So writing it like this is bad form. All right. This is not really mathematics. This is just scratch work or something. If you don't have an argument, if you don't have an angle, then tangent and secant and sine don't mean anything unless you actually attach an angle to them. We experienced that in the last section. We were talking about logarithms and things. You can't just say log without actually having an argument to have a log. Well, a trig function is very similar to that. It has the same basic idea. You must have an argument. So don't do this. Okay, you can write it this way, or you can write it this way, but be correct. Well, let's try another one. Example 4. Let's simplify secant t over cosecant t. All right, so secant. This one actually, there's two ways to do it. Let me show you one way to do it. Secant is 1 over cosine. Cosecant is 1 over sine. So this is 1 over cosine times sine over 1. Again, multiply by the reciprocal. So I've got sine times 1. Well, that's just going to be sine. And cosine times 1 is just going to be cosine. And sine over cosine is tangent. And I take that back. I don't really see another way to do this problem. This is the best way to do it. All right, well, those are the basic, we call the basic trigonometric identities, or the fundamental trigonometric identities. There's a few more that we're going to, a new class of trigonometry. We have what are called the Pythagorean identities. Come on back to me. Focus. There we go. So the Pythagorean identities. Remember that all of this comes from a triangle. A unit triangle, and the angle is our t. Okay. This is the same thing as a general right triangle with an angle theta. A, B, and C. The only difference is in the unit circle, the hypotenuse is 1. In a general right triangle, the hypotenuse is not necessarily 1. Okay. So where do we get this Pythagorean identity from? Well, the Pythagorean theorem says a squared plus b squared is equal to c squared. Or in the unit circle, x squared plus y squared is equal to 1 squared. So if you're talking about the unit circle, the hypotenuse is always 1. In general, you could have a larger triangle or a smaller triangle where the hypotenuse is not 1. In general, we call the hypotenuse c. Okay. Either way, you're going to get what's called the Pythagorean identity. Remember that y is equal to sine, and x is equal to cosine. So this is cosine squared and sine squared, because y is equal to sine and x is equal to cosine. And then in order to get rid of some of these parentheses to make it easier to write, we put the exponent between the letter s and the letter t. That's the indication that the entire cosine is being squared. It also makes it a lot easier to write so that you don't need all of these nested parentheses. You can just write it this way. Okay. On the computer, you'll probably have to put some parentheses around the t's if you were typing this on the computer. For the general right triangle, what we do is we divide both sides by c squared. So that the right side is 1. And then if you remember the right triangle definition, sine is a over c, and cosine is b over c. So sine is a over c. Cosine is b over c. So this says the same thing in terms of the angle theta. So either way, you have what's called the Pythagorean identity. Cosine squared plus sine squared is equal to 1. The angle could be theta. The angle could be t. There's lots of different variables that we could use for the angle. We could even just use x, although that causes some confusion because x already means something, but we'll talk about that in a minute. For now, this is called the Pythagorean identity. I'm going to go ahead and work with this version of it, although these are identical. Just a different variable here. Okay, so you've got cosine squared plus sine squared. Notice where we put the squared. That's sometimes called the shoulder. It's like the shoulder of the function is equal to 1. You only have to memorize this one. And you're going to get 2 more for free. Okay, so let's see how this works. Memorize this one, and then you're going to get 2 more for free. Let's start by dividing everybody by cosine. For simplicity, I'm going to omit the parentheses while I'm writing, because they really don't contribute anything to my calculation. So start by dividing everybody by cosine to get your first free identity. That's going to give you 1 plus tangent squared is secant squared. All right. I'm just bullet pointing these. And then the next one, well, to get the first freebie, you divide by cosine. So take a guess. How do you get your second freebie? Well, divide by sine squared. Divide everybody by sine squared. And you're going to get cotangent squared plus 1 equals cosecant squared. So these are your 2 free identities if you memorize the original Pythagorean identity. All of these are called Pythagorean identities. Okay, so these are all called Pythagorean identities. I'm sure you can't wait to see an example. Example 5. Simplify sine t divided by secant t minus cosine t. Okay, so remember, sines and cosines can be left alone. Leave those unchanged. Anything that's not a sine or a cosine, write it in terms of either sine or cosine. So secant would be cosine. I'm also going to omit my parentheses while I'm working. I should have done that originally. It's just a lot less messy if you don't have all the parentheses. And then put them back, and your final answer will put the parentheses back. Okay. All right, leave the numerator alone. That's just sine t. The denominator now, you want to do a common denominator. So if you do not see a denominator, you're going to put an invisible 1. And then you're going to multiply by the LCD, which is cosine of t. Your least common denominator is cosine t. So that's going to give you 1 minus cosine squared t over cosine t. Notice when you multiply these cosines together, you get cosine times cosine, which we write as cosine squared. Be careful that you don't do that. That would be bad. All right, this is bad. That would mean that you're squaring the t. You don't want to square the t. You're squaring the cosine of the t. All right. So now let's come over here. We've got our Pythagorean identity. Sine squared plus cosine squared equals 1. So if you subtract cosine squared from both sides, this is your mental math. You could do this in your head if you got a good understanding of trig. You could subtract cosine to the other side, and you're going to get sine squared t is 1 minus cosine squared t. So that tells you that you can rewrite your 1 minus cosine, you can rewrite it as sine squared. Okay. I probably should have kept working vertically, but I felt like I was getting a little pinched in here, so I wanted to move over a little bit. So now I've got sine t over 1 times the reciprocal, which is cosine t over sine squared t. Here's a neat trick. Instead of writing sine squared t, watch what I do. I go back to basic math and I remember, what does a square actually mean? It means to multiply sine times itself. So that's my trick of rewriting sine squared as sine times sine. It's not really a trick, it's just the truth. It's just showing the reader what sine squared actually means. And now I cross off sine t because that's 1. And my answer is cosine over sine. I want a single trig function if possible. So the answer is cotangent t. And that's my answer. Put the parentheses back when you type your answer on Canvas. Otherwise, it won't recognize the function that you're writing. It'll think it's, it'll think it's COTT. And the computer won't know what COTT means. So you have to put parentheses around the second t so that it knows that that's the argument. Okay. All right. Well, let's do some more Pythagorean identities. Simplify. One plus secant over 1 plus cos. Now keep in mind, you need squares to use Pythagorean identities. If you do this, quickly and you don't read it carefully, sometimes the mind will see a square there. All right. And here's what you're not allowed to do. You're not allowed to just square the top and the bottom to force it to be x or cosine squared or secant squared. You can't just introduce an exponent because the squares are required. But what you can do is you can multiply by 1. That's the most common trick in this section. This is what we call a special form of 1. All right. All you have to do is look at the denominator, change the sign. So if it's already negative, change it to a positive. If it's positive, change it to a negative. and rewrite it using the same denominator with an opposite sign. Okay, in complex numbers, we call this the conjugate. In irrational numbers, we call this rationalizing the denominator. In trigonometry, we call this simplifying the trigonometric expression. So we don't really have a much fancier name for it than that. All right. So we're going to multiply using what we used to call FOIL in basic algebra. So 1 times 1 is 1. 1 times cosine, it's a negative, so that's negative cosine. For the rest of the calculation, I'm going to omit the parentheses. 1 times secant, that's going to be secant. And then secant times cosine, that's a positive times a negative. So that's going to be negative. I'm running out of room. Sec cos. Oh, that's terrible. Let's try that again. 1 minus cos plus sec minus sec cos. There we go. Just barely got it in there. Do the same thing in the bottom. Multiply these together. So the first pair, 1 times 1. And the second, the outer pair, that's negative cos. Then the inner pair, that's positive cos. These are always going to cancel. Probably in my next example, I'll just skip that step because we'll know that that's going to happen. And then finally, a positive and a negative is a negative cosine squared. Okay. Or you could write cos cos. You could write it out twice. I'd rather have you write it out twice and get it right than try to skip it and get it wrong. All right. So now we have 1 minus cos times plus sec. Now remember, secant and cosine are reciprocals of each other. So that's just going to be 1. Yeah. Recall that from a previous section? Secant and cosine are reciprocals of each other. If you want to see the math, it would look like this. 1 over cos times cos. And those would cancel, and you would just get 1. These guys are always going to cancel. The middle terms always cancel. So now the bottom has 1 minus cosine squared t. So now I have a 1 and a negative 1, so those are going to cancel. So now I have negative cosine t plus secant t over, what's 1 minus cosine t? Sine squared t, as seen in example 5. So example 5, we already showed you that 1 minus cosine squared is sine squared. Okay. So where are we now? So now we've got to resolve the numerator here. I might need a little bit more space over here. So I've got negative cosine t plus 1 over cosine t. All right, that's the numerator. And then the denominator is sine squared t. I'm going to need some more space. We're going to need a bigger boat. All right, so I'm coming around here just to give you some more space here. So I need to do a common denominator here. Yeah, so I'm going to multiply this by cosine. Let me show that step down here. I'm going to multiply top and bottom by cosine, numerator and denominator of the term here by cosine to create an LCD. So I'm multiplying by cos. I don't know if I wrote that big enough for you. Hopefully that helps. Okay, so now I've got, let's just rearrange this, 1 minus cosine squared t over cosine t all over sine squared t. Well, again, I've got 1 minus cosine squared again, so I've got sine squared again. So now I'm going to flip the reciprocal. It's getting very messy here. Let's see if I can finish it in one step. So this is going to be sine squared over cosine times 1 over sine squared. The sine squareds are going to cancel. And I'm going to get 1 over cosine. I know I'm running out of space here, but this is the last step. 1 over cosine is secant. And so that's your answer. The answer is secant, and I better put the parentheses back. Secant t. Whew, that was a big one. If we were in the classroom, that probably would have filled up both of my boards. Sometimes you get lucky and the squareds are already there. So this symbol is theta. It means the same thing as t. It's just a Greek letter t. It's theta. I know it doesn't look anything like a t, does it? Looks like an O or a 0 or something, but it's theta. So in this example, we already have the squares. Yeah, it's kind of like a gift. So remember, cosine squared plus sine squared is 1. So if you subtract sine squared from both sides, you get another identity. Cosine squared is 1 minus sine squared. So personally, I only memorize the fundamental Pythagorean identity. And then if I need another one, I just take that one out and I rearrange it to get another one. Now, you might, through repetition, end up memorizing this one anyway. It only takes, one or two times and be like, oh, okay, I've seen that before. So if you've seen that before, you can skip a little bit of your mathematics and just jump right to this. 1 minus sine squared is the same thing as cosine squared. All right, so you can use an identity that you've run into previously and say, hey, I've already done that one, so I can use it again. So this is the same as sine theta over cosine theta all squared, which is tangent theta squared, which we write as tan squared theta. On Canvas, you got to type it like this with a lot of parentheses. For theta, the symbol, just type the word theta in parentheses. I don't use this symbol very often in this initial chapter, but there's a few of them in there just to kind of get the argument out there. Most of the time I either use an X or a T or something easy to type, but I am going to be introducing a lot of the Greek alphabet in this chapter. I'm just starting one letter at a time. So for 7.1, you need to know one Greek letter, which is theta. I might regret that I just said that, but we'll get to that in a little bit. Okay. Let's try another one. One where the squareds are already given. So we have tan squared. Let's use a simple argument like x minus secant squared x. Okay. So tangent squared. Tangent squared means sine squared over cosine squared. Yeah, everything in terms of sine and cosine. And then simplify. Okay. So we're going to write it in terms of sine or cosine or both, and then simplify to a constant if possible. So secant is 1 over cosine. Oh, I love it when that happens. You just get lucky. You already have a common denominator. It means you can skip the LCD step. You already have an LCD. So the numerator is sine squared minus 1. Denominator is cosine squared. Now you got to be careful. That's one of the problems with memorizing identities is you might memorize them and then regurgitate them backwards or something, in which case it's not an identity. This is almost an identity. You got to be careful. Remember, there's my little brain cloud here. I got sine squared or cosine squared plus sine squared. I'm using x for my angle. X is like t, just means the same thing. Okay. So I want sine squared minus 1. Yeah. So I'm going to subtract 1 from both sides. So I get cosine squared plus sine squared minus 1. So that's what I'm looking for there, sine squared minus 1. But I need to get rid of the cosine. So I'm subtracting cosine squared from both sides. And now you see the truth. The true identity is not what you might have thought it was. It's the opposite. So make sure you check your head, because sometimes the mind will make up an identity that's not actually true. Happens all the time. So it's not the one you might have thought. It's the opposite. It's negative cosine squared. So that becomes negative cosine squared. Remember that a negative just means -1. So when you cross these out, don't just put a negative sign. Your final answer is -1. That's your final answer. So I simplified it to a constant if it's possible. You want to go as far as you possibly can. Let's actually plug some numbers into our functions and see what happens. So I got 3 parts that I want you to do here. I want you to find sine squared, I want you to find cosine squared, and I want you to find the sum of the first 2 parts. Okay. A quick review, because in this section we haven't done any actual angles. This is an angle in radian measure. I'm not sure how much you remember, but the only thing you really need to memorize is that 180 degrees is half a circle. That's pi. All right, so you think of an angle starting over here and going 180 degrees counterclockwise. This is pi radians. That's the only one you really need to memorize, because that means that 180 over pi is equal to 1. Yeah. So if you're not quite sure what pi over 3 is, you multiply by 180 over pi. That cancels the pi's, and you get 60 degrees, in case you forgot. Hopefully you remember that from Math 5. So what is pi over 3 in radian measure? Well, you have a couple different ways of remembering it. I remember it as a triangle, 60 degrees. That's our x. All right. And then I've got 1, 2, and square root of 3. This is one of the special triangles that I hope you all remember from Math 5. Okay. Or you can think of it as the unit circle. Now, the unit circle gets a little tricky when you're using x as your angle, because now I can't use x as my axis. So what I do, and different teachers have different ways of approaching this, when x becomes my angle, well, then I can't allow this axis to be x. So I call this the a axis, and I call this the b axis. And then my unit circle is just a squared plus b squared is equal to 1. But either way, you can think of it as a 60-degree triangle, or you can think of it as a unit circle where x is pi over 3. This length is pi over 3. That's the arc length from 1, 0 to this point, AB. This distance is pi over 3, which is just a little bit more than 1. If you memorize it this way, it's kind of neat because A is automatically your cosine, and B is automatically your sine. I don't know where to put it. I'll just put it down here. All right. And so you get those relatively quickly from the special triangle. Cosine of 60 degrees is 1/2. Yeah, 1 divided by 2. And sine of 60 degrees is radical 3 over 2. That's if you memorize them from Math 5. If not, you've got a week or so to get caught up or to get refreshed before we really start getting into the deep end of the pool. All right. So either way, you've got your sines and your cosines. If you do it in the unit circle definition, you get A is cosine, which is 1/2. That would be this distance here, 1/2. And then B would be the vertical distance would be B. B would be sine. B would be radical 3 over 2. Okay. All right, so that's your quick review of radians and degrees and sines and cosines. Let's get back to the topic at hand. So what are these guys? So sine x is B, that's radical 3 over 2. So sine squared x means radical 3 over 2 squared, which is 3/4. So there's your sine squared. Let's do cosine squared. So cosine x is 1/2. So cosine squared is 1/2 squared. And that's the reason why we emphasize that it's not squaring the x. You're not squaring the angle. You're squaring the output, the cosine, which is 1/2. So that's 1/4. All right, so check, check. I got my sine squared and my cosine squared. And now I want to know what is sine squared plus cosine squared. Just use these values. That would be 3/4 plus 1/4, which is equal to 1. Notice it's an identity. Yeah. If you didn't get 1, then you definitely did something wrong. So it didn't matter that it was pi over 3. Yeah, it would have been 1 no matter what for any x. In particular, pi over 3. So this was just a demonstration of one specific example that makes this true. But this particular identity, sine squared plus cosine squared, is always equal to 1. Okay. Next, we're going to talk about cofunctions. Co means complementary. complementary functions. So let's talk about a triangle, a right triangle, theta. This angle is the complement of theta. So whatever theta is, this angle here is the complement of theta. All right. Let's call it x. Okay. So let's call this angle x. Yeah. If these are complements, complement means it adds up to be 90 degrees. Or in radians, pi over 2. All right. So if these are complementary, I don't really even need to use the letter x. I can move my x to the other side, and I get theta. Sorry, move my theta to the other side. I'm not stopping the tape for this one. I just moved the wrong variable. I want to move my theta to the other side, and my x is 90 minus theta. It's what we call the complement. Okay. So that's my x. So let's look at the sines and the cosines. Let's call this B, A, and C. Yeah. Those are the sides of the triangle. Sine of theta is A over C. Cosine of theta is B over C. You might have remembered SOHCAHTOA, or sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So these are cofunctions, because if I want to know what sine of 90 minus theta is, 90 minus theta is the same as x. It's this x angle here. That's going to be B over C. That's the same as cosine of the complement. Yeah. So the word cosine means complementary sine. But nobody wants to say complementary sine, complementary sine. Nobody wants to say that. I don't even want to say that. So we say cosine instead. Similarly, if I wanted to know the cosine of 90 minus theta, I could just look up here at the sine. That would be A over C. That would be the same as sine. Again, that's the complementary sine. So these are called the cofunction identities. Okay. We might as well list them all out while I've got some time here, or while I've got some space here. So you have the sine and the cosine. So let's go ahead and write them out. We have sine of x is equal to cosine of pi over 2 minus x. Again, pi over 2 means the same thing as 90 degrees. Cosine of x is the sine of pi over 2 minus x. Tangent of x is the cotangent of pi over 2 minus x. Cotangent of x is the tangent of pi over 2 minus x. Again, pi over 2 is the same as 90. And then for the secant and the cosecant of x is the cosecant of pi over 2 minus x. And the cosecant is the secant of pi over 2 minus x. I only memorize one of these. Buy one, you get the other 5 for free. All right. Or you could try memorizing all 6 of them. That's fine. I only memorize one, and then I get the rest of them for free. Okay, so wrap this up with a couple cofunction examples. So simplify secant 90 minus t. Simplify cosine pi over 2 minus x. And simplify tangent pi over 2 minus u. Just to give you a variety of different arguments that you might see. These are all just mental math problems. You just look at them and write down the answer if you remember. So secant, complementary. So that's the complementary secant. That's CSC of just t. Cosine. Cosine, complementary. The complementary cosine would be the sine of x. And tangent, complementary tangent, is called the cotangent of u. Okay, so that's the end of part 1. 7.1, we'll have a continuation tomorrow. Peace.